Hello everyone, I am Dr. Tanmay Vishwas. I welcome you all in my channel Tanmay Kim. Today's topic of discussion is on MCQ and the question is in front of you. I request everyone please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now the question, which of the statement is true regarding these two molecules? Okay, phenyl lithium adds with both compound with equal reactivity, different reactivity, or preference in reactivity in case of one or two. Okay, so it's a very interesting problem, but before going to the main problem, let's learn the background of this question. What is the background is related to aromaticity, means this bond breaks down heterolytically, negative charge comes here, positive charge there. Similarly, it breakdowns in this way, opposite direction, produce positive charge here, negative charge there. What is the benefit? In this case, this negative charge is under delocalization or resonance, is delocalized. Why? Because this part is aromatic in nature. Similarly, if you look at why positive charge is here, it is also stabilized because of its aromaticity in 6 pi electrons. So both are aromatic in this way, and remember, aromaticity means stability. So since in this way a molecule can attain stability, so such kind of splitting of double bond is preferred. Okay, now in this case, if you look at another part, there is the phenyl lithium. What this reagent actually is, because of the difference of electronegativity between carbon and lithium, this bond is very polar covalent bond. Okay, now that's why this carbon center has extra electron density, which is represented by delta negative, lithium deficiency delta positive. So from this discussion, student, can I say that this carbon can act as nucleophile? Yes, it can act as nucleophile. Not only nucleophile, it can act as base also, depending upon the reaction condition. But if you look at this carbocation, by the way, carbocation, if I say it is electron deficient, because positive charge indicates the deficiency of electron, but negative charge, the other part, it is electron rich. Okay, so nucleophilic attack cannot take place here. But in this case, I believe compared to nucleophilic attack, there is a better option, that is basicity. Means this neighboring proton could be abstracted by phenyl lithium while it is acting as base here. So what it will do, it will abstract this proton and it will produce a carbon ion here, and that carbon ion can participate in resonance in this way. You'll get this structure. Okay, so obviously just sometime before we have discussed this is aromatic according to Huckel rule. I'll explain. Here also the opposite, if you do the similar thing, means this proton abstracted, negative charge, means this abstract this proton, the negative charge goes on that carbon, and if you do the resonance, so this part, student, if I say this is anti-aromatic. Why? Because they are 8 pi electron and they are in conjugation, and remember, anti-aromaticity means instability. That's why molecule try to avoid it, and in this way how can it avoid? Obviously abstraction of this proton will be difficult, acidity will be very less, but here the acidity will be significantly higher as the conjugate base is resonance stabilized. Not only that, it is aromatic, means stable. So that's why this reactant 1 will get preference in reaction compared to reactant 2 with phenyl lithium, and this case phenyl lithium is acting as base here. Clear, student? Now you may ask one question, sir, why not the opposite thing? Just look at this previous one. Here you have a positive charge because of resonance. So can phenyl lithium attack this carbocation? Answer is, if it attacks also, the aromaticity, means the stability, that will be deviated or disturbed. So from that point, if you say that, sir, let's break the bond in this way, still if phenyl lithium attacks or reacts with this, that will result in instability. So that's why I can conclude that phenyl lithium will react this compound number 1 preferentially than compound number 2. And here the Huckel rule, compound must be cyclic, planar, conjugated, each one having p orbital, and if they are 4n plus 2 number of pi electrons, aromatic, 4n pi electron, it's anti-aromatic. If you look at here, there are 6 pi electrons. So according to the 4n plus 2 rule, here n value is 1. Okay, so this is aromatic and stable. But if you look at here, according to the 4n pi electron rule. So n value 2, so 8 pi electron, this is unstable. So if you want to learn Huckel rule further, I have already uploaded dedicated lecture on it. Please visit for further learning. Now here, what is the answer? Phenyl lithium preferentially reacts with 1 than 2. So this option C is the answer. I know, student, this is a very easy question if you know, but if you do not know, it's a confusing. Now, if this question is given in your exam, how can you explain? Two factors you need to understand. First, aromaticity. This breakage of this double bond heterolytically and aromaticity. If it goes there, positive charge is confined here. So nucleophilic attack also you may think like that, but here I'll say proton abstraction get more preference, better. So that is, if proton abstraction, that will not result stability. Even if say, sir, nucleophilic attack can take place on this carbocation, I have explained not possible, because aromaticity will be disturbed in that way also. So phenyl lithium will react with this one preferentially. Student, in this case, remember one thing, that if I say phenyl lithium adds with both compound equal reactivity, student, not possible. Here the aromaticity pattern is different, wrong. Now both compounds with different reactivity, yes, it could be one option. Another thing, phenyl lithium reacts preferentially with which one? Now remember, when you solve MCQ, there will be some situation where it may look like that more than one answer is correct. Then what will you do? Actually, I'm talking about B, C or D. In this case, how can you decide? You need to understand about the reactivity pattern. Okay, so if you think that, okay, sir, addition takes place or not doesn't matter, but which case it will react preferentially? Obviously, option A. That is more accurate statement. Yes, I'm not saying that, okay, reacts with both compound with different reactivity. It is also accurate, but compared to this option, this C is more accurate to the point. So in this case, you should take this option C. That is a better choice. Okay, so this is the overall discussion. I believe you have learned a lot. So thanks for watching. See you in my next video. Bye bye.